All right, guys, so let's go ahead and start sketching some graphs. Okay, we're going to do this without using any decimals or anything. So it's just a sketch. It's not totally accurate. It's just to give us an idea of what a graph looks like. So the first thing we want to do is let's first start by answering these questions, okay? So we'll start with our degree. To start with our degree, remember, it has to be in factored form, which we do have, okay? So factored form, because it's in factored form, I'm now going to count each exponent for every factor that has an x in it. So this is a factor of x, and it has an exponent of 1. This has a factor of x, so it has an exponent of 4. And this guy is a factor with the x, so it has an exponent of 11. So when we are in factored form, we have to add all the exponents. So we're going to add 1 plus 4 plus 11. And that gives me 16. Okay? So what does that mean? It means that our degree is even. Okay, so keep that in mind. That's the important part of it. It's an even degree. We'll come back to that in a little bit. Now our leading coefficient, we look to the front of our factored form. What's the number in front here? So the number in front is a 1. So our leading coefficient is equal to 1. But what's important about this is it positive or negative? Okay, so now with these two pieces of information, we can get our end behavior. How do I do my end behavior? I'm going to sketch it, okay? So what we really want for our end behavior is on the right side, is it going up or down? So how do I determine that? You look at your leading coefficient. So on the right side, since my leading coefficient is positive, that controls the right side. Since it's positive, that means my graph is going to go up on the right side, okay? If it's negative, if this was negative, it would have went down on the right side. So now we know that the right side is going up. On the left side, we look at our degree. Because it's even, that means it's going to be the same as my right side. So even means the same. So my left side is going to do the same as my right side. So that means my left side is going up as well. Okay? So that is my end behavior in sketched form. But what we want to do is we want to go ahead and write it out. Okay? So we are going to go ahead and write this out. Remember, we write it out in this format. Okay, so when we write this out, we want to fill in the blanks real quick. All right, so we're going to do the right side first. So the first blank we want to fill, how far the right side is represented by positive infinity. That means right side, because remember, positive infinity is on the right. And on the right side, am I going up or down? I'm going up. And when we go up, we're going up to positive infinity. Okay, we're going to do the same for the left side. The left side is represented by negative infinity. Okay, so what are we doing on the left side? Left side is going up. It's also going to positive infinity. Okay, so now we're going to do zeros and end behavior. So what does zeros mean? We're going to take each factor and set it equal to 0. Okay, and solve. So any factor with an x, put it equal to 0. We're going to ignore the exponents. All right. So we're going to have x equal to 0 is my first factor. Then we have x minus 5 equal to 0. And then x minus 3 equal to 0. And let's solve for each one of them. So this one is solved. Add 5 to both sides. X equals 5. Solved. add 3 to both sides, x equals 3. Okay, so we have those zeros, and now we want to determine what's their behavior. Remember, we have two options for behavior. We have it crosses, or it bounces, or is tangent. Okay? And how do we know which one's which? It is determined by the degree. So crosses is an odd degree, and I'll show you where to find that again. If it's tangent, it's an even degree. Okay? So let's check this out. So let's go here first. X equals 0. We go back to factored form. So in the factor form, x equals 0 came from which factor? It came from this factor. Okay? So what's the degree of this factor? The degree is odd. It's 1, which makes it odd. Because it's odd, we're going to have a is going to cross. And I'll show you what that looks like when we graph it. Okay? Now let's go to the next fact. 0 is x equals 5. This came from what factor? It came from this factor. Okay? X minus 5 turned into x equals 5. So it came from this factor. What's its degree? It's 4. That means it's even, which means it's going to be a tangent, or it's going to bounce. Okay? Now let's go to the last 0. X equals 3 came from this factor, and we have an odd degree here. So since it's odd, it cross. It will cross. Okay? So we have all this information. Let's graph or sketch our graph. So okay, so we have this. Again, this is not totally accurate. It's just a sketch. So the first thing I want to do is I'm going to put in the zeros. So let's mark these off. Okay. So our first 0, again, when we say 0, is really your x-intercept. So x equals 0. So let's put that in as a point here. Okay, for that guy, that's the first thing you want to do. Second, then we're going to do this guy. X equals a 5. 1, 2, 3, 4, 5. Put a dot here. 0 is always go on your x-axis. And x equals 3. 1, 2, 3. So we have these 3 dots. Okay, these are your zeros, and what they represent in the graph is this is the only part of the graph that's going to touch my x-axis. Okay, so let's go ahead, and once we have our zeros in, the next thing we want to do is end behavior. So we know on the left side our graph is going to be going up. So we'll put a little sketch here, an arrow going up. Okay, we're going to use that arrow. On the right side, my graph is also going up. Okay, we already determined that. So on the right side, my graph is going to be going up. So I'm going to put a little arrow here. Okay. So now we are going to sketch this thing. So I like to start on the left. Okay, since my graph is going up, I know I have to touch my first dot. So my graph has to come down, and then it has to touch my first dot. Okay, so I'm going to draw that in. So it's going to come, it's got to touch my first dot. So before I touch it, my first dot is 0. And we now know that at 0, my graph is going to cross. Okay, so it's going to cross. See how I'm crossing it? I cross the x-axis there. Okay, so this is a sketch. I can't go down forever and ever because guess what? I have to touch this dot now. So that means I got to curve back up. So this is the sketch part. I'm going to curve back up. Okay. Curve back up because I got to touch the second dot. Before I touch the second dot, let's understand that the second dot is 3. So it's odd, which means at the 3 dot is going to cross again. So we're going to cross over to the other side. So we're going to cross at that dot. But I can't go up forever because I have to come back down and touch this dot. So we're going to sketch it back down. And before I touch that dot, this dot is 5. And we know it's a tangent or a bounce. So that means I'm going to touch the dot and bounce off of it. I'm not crossing it. Okay? So it's a tangent and a bounce, and I connect it to my other end behavior. Okay? And that's how you sketch the graph. All right? So summary real quick. We have to fill in this stuff. You should be comfortable finding degree and leading coefficient. Using the leading coefficient and degree, we should be able to sketch in the end behavior here. Remember, leading coefficient, positive means right side goes up. Negative means right side goes down. Okay? You have to memorize that. The degree determines the left side. If it's even, it does the same as the right side. If it's an odd degree, it does the opposite of the right side. Okay? This is all in previous notes, so make sure you get comfortable with memorizing that. All right? Again, this is how you write end behavior using function notation. So this takes a little practice, but you'll get used to it. And then the zeros, in order to find the zeros, we have to put it in factored form. So luckily, this is already in factored form. We put each factor equal to 0 and solve. So the first factor was x, we put it equal to 0. Second factor is x minus 5 equal to 0 and solve. We get x equal to 5. X minus 3 equal to 0 and solve. We get x equal to 3. Okay? Once we have those, we then can decide, is the degree of each factor, is it odd or even? So x equal to 0, what's the degree there? It's 1. That's odd, which means when I graph it, I have to cross over. Okay, I got to cross it. X minus 5 turned into 5. What was the degree of x minus 5? It was even. That means when I touch it, I have to bounce off of it. Tangent, a bounce. You're not crossing over. And then the last one, x equal to 3. It came from this factor. It was odd. That means at 3, we're going to cross, like I did here. Okay, so let's try number 11. So number 11 is not in factored form. It's in standard form. So that means my degree is just the highest powered exponent, which is going to be 3. So my degree is 3, which means, is it odd or even? That means it's odd. Okay, so just keep that in mind. Now we want to look at our leading coefficient. My leading coefficient is the front number here. And again, this is a 1. So leading coefficient is 1, which makes it positive. We only care about if it's positive or negative at this point. And again, just to go back, when you have it in standard form like this, you just take the highest power for degree. Do not add these up. You only add them up when it's in factored form to figure out your degree. All right, let's sketch end behavior. So just a real quick sketch so we can know how our graph's going to start off. So on the right side, our right side is controlled by the leading coefficient. If it's positive, that means the right side goes up. So I'll put a little arrow just to help me note that I'm going up on the right side. The left side, if it's even, it does the same thing as the right side. But as you can see, it's odd. So it's going to do the opposite of the right side. So since the right side's going up, because the degree is odd, the left side's going down. So it does the opposite. Okay, let's go ahead and write that in real quick. So again, we're going to write this in x and then f of x. We have x and f of x. So your right side is always positive infinity. So we're going to talk about positive infinity side. And what's happening is it going up or down on this positive infinity side. It's going up, which means it goes up to positive infinity. Left side is negative infinity. So we put negative infinity here. Is it going up or down? On the left side, it's going down to negative infinity. Okay, so that's how you write end behavior. Now here's some work we got to do. We got to find the zeros. So if you notice, in order to find the zeros, we must put it in factored form. So this is going to take some work. We got to factor this bad boy. So I'm going to rewrite this guy, and we're going to factor it in order to solve for all the x's. So we have x to the third minus x squared minus 4x plus 4. Okay? And remember, when we factor, in order to put it in factor form, this is our weapons. GCF, diamond, snowflake, and can't forget factor by grouping. Okay, so we've practiced these last couple weeks. So if you look, we always check for GCF. Can I divide all these by the same number besides 1? And the answer is no, no GCF. Do they all have the same letter? Nope, the last guy does not have an X, so no GCF. Can't use that. Is it snowflake diamond or snowflake, or X or snowflake? And the answer is no, because it's an odd power. In order to use these two, we need an even power in the front. Since it's odd, we cannot use these methods. The only methods left is factor by grouping. And how do I know it's factor by grouping? It's because we have 4 terms. 1, 2, 3, 4. And factor by grouping, if you remember, we have to split this guy. Okay, so if we split, we're going to GCF these two guys, and the GCF here is going to be x squared. Okay, that's not the number 1 can divide, but we're not going to use 1 here. They both have an x in common. We picked the lower powered x. It's x squared. Divide that out. So we have x minus 1. Again, x to the third, divide out 2 of them. You're left with 1x. X to the second, divide out 2 of them. You're left with nothing, but we still have the 1 here. So they kind of cancel out, but you're left with the 1 there. So that's why you have minus 1. Parentheses, and your GCF goes in front. Okay? Over here, our GCF is going to be negative 4, because our first guy's negative. The rule is you want to take a negative GCF, and 4 can divide both these. They do not have an X because this guy does not have the same letter. So GCF is negative 4. Divide both guys by negative 4, and you get X minus 1, parentheses, and our GCF is negative 4. Okay, so now we got to regroup. As long as the stuff in parentheses is exactly the same, that means we're doing it right. We're going to group the GCFs into one parentheses. So x squared, the first GCF, and then my second GCF goes in one parentheses. The parentheses, since they're the same, they go in their own parentheses. So it looks like this. Okay, we're almost to factored form, but we got to check. You should notice we have a power of 2 here. This is the ABC pattern, which means I can use one of these methods here, or at least try to use one of these methods, because these are power of 2 methods or even power methods. So here's my A. We are missing the B, but we do have a C. So I'm going to rewrite this with my B in there. So we have x squared plus, here's my B that I'm writing in, 0x, because it was missing. And there's my C, minus 4. So let me relabel these for you. My A is 1, my B is 0, and my C is negative 4. And I'm going to do X method. Okay, and the reason I'm doing X method is because the A value is 1. So 1 times C, or A times C on top, that's negative 4. B value goes on bottom, which is 0. What multiplies the negative 4, that adds up to 0. Negative 2, positive 2. And now I can put that in factored form. So this turns into factored form. My magic pair is negative 2 and positive 2. Okay, again, where did I get these x's from? I split this guy into 1x here, 1x here, and then put our magic pair. Don't forget, bring down the x minus 1, and we put him here. Okay, so we have just turned this guy into factored form. And now if you recall, I want the zeros, so I'm going to split these guys up and put them equal to 0. So split them up. We have x minus 2 equal to 0, x plus 2 equal to 0, x minus 1 equal to 0. I know the watermark's there, but hopefully you can see that. Solve here. So we're going to add 2 to both sides. So I'm going to do some math in my head. That's going to give me x equal to 2. Subtract 2 to both sides. This is going to give me x equal to negative 2. Add 1 to both sides. That's going to give me x equal to positive 1. Okay. So now that we have the zeros, okay, we found the zeros. We want to know, are they crosses or tangents? So x minus 2 came from this parentheses. What's the power here in this parentheses? And you'll notice it's a power of 1. So that means since it's odd, just like we showed up here, since it's odd, that means it's going to cross. Since my degree is odd, that means it's going to cross here. The next one, x plus 2, which is this guy. He came from here. What's his degree? He's 1. Again, he's odd. That means we're going to cross here as well. And the last one is x minus 1, which is this guy. What was his power? His power was 1 as well. And he's going to be across. Okay? So now we have all this information. Let's sketch our graph. Let's see if we can do this right. Okay, first thing we want to do is put in our zeros on the x-axis. So let's put these bad boys in. So the first one I want to put in is x equal to 2. So we'll put that there. The next one is going to be x equal to negative 2. There it is. And then the last one is x equal to 1. There we go. Okay, once we have that, we then sketch in our end behavior. So we have that already. On the right side, I'm going to go up. So we're going to go up on the right side. On the left side, I'm going down. So we're going to go down on the left side. So something like this. Okay, so now we just got to connect the two arrows by going through these dots. So I like to start on the left side. So we're going to start down here, but we have to go towards this dot. So let's start drawing that. go towards the dot, but before we touch it, how are we going to touch it? Do we cross through it, or are we a tangent? Do we bounce off of it? So this is a -2. So which one represents -2? Here he is. We already know we are going to cross, which means we're going to cross past it. So we can't go up forever and ever and ever. We can't do that because we have to come down here. So we're going to go up, and then when you feel like it, make a turn, and we're going to come down because we got to touch this dot. And this dot is at x equal to 1. So what is happening at x equal to 1? We are going to cross at x equals to 1. So we cross, but we can't go down again forever and ever because we have to come back up and hit our next dot. But before we do, what do we have to do? This is +2. And what do we do at +2? We are going to cross again. So we're going to cross it and then connect to our other arrow. So that is your sketch of these two graphs. Okay, again, it takes some practice. You got some more problems to do. If you need extra help, stay on Zoom. I'm going to go ahead and give you that check-in code and get you out of here.